Okay, y'all. Appreciate you coming. The questions, you want to start with questions, particular questions that you have?
Is that on our quiz?
That? No.
Okay, I was just curious.
No, so it's just vectors and 2D motion. So anything about vectors, you're going to see like graphical, you're going to see I'm going to give you vectors and ask you to add up the vectors. You're going to see our putative 2D problem start and stop at the same point. You'll probably see one of those where it just goes off at a horizontal. There are 8 questions, okay? 10 minutes, maybe 11, we'll see. I think 10 should be enough. Yeah.
Okay, so if we're on the X-range ones, there's some where we use T total and some where you just use like the T at the top. So how do you know which one you use the T total?
Okay, so on the X range, you almost always use the T total for finding the X range, because remember you have motion that's like this, right, where it starts off at this point and it travels through this path. And if I want to know the position at this point, then I need to know the time at that point. If I want to know the position at this point, like my y height, then I need to know the time at that point. So it depends. The time that you use will depend upon which position do you want. Do you want to know the full X range? If that's the case, you need to know the full time, which is twice the time that it is here. If you want to know just half the range, like right here, then you use T top.
Okay, so like the ones that start off with cliff and go down, those are like the ones where you use T top. Because on all the homework problems we did.
I know, so those are different.
Okay.
Well, those are really just like half of this problem, you realize, right? Yeah, so these, I have a path like that. And if I want to know X range, then you're right. This is sort of like just using T top in the sense that it's just using, it's like the time here is half the time that you would have over here because it's half the trajectory. So on this problem, I would want to know the time here. And in order to find the time there, the way I approach that is I say, okay, I'm going to think about this object right here. I'm going to ask how much time does it take to just drop? Because the amount of time that it takes to drop, go from here to here, is the same as the amount of time that it takes to go in this path, right? If I drop two things, or if I drop and kick one off, they both land at the same time. And to find that time, like if I know what y is, say y is equal to 2 meters, then I just say y is equal to 1/2 at squared. Because v naught y is equal to 0. I know a, that's minus 10. I know y in this case, it's -2. Remember your negatives, it starts at 0 and goes down, so it's -2. And I can find t. And then when I find t, I can find x, which is equal to vx times t. And I'll use the whole time for that one. Because the whole time is the time that it takes to go from here to here. This is t equals 0. This is my t final. So the hard part about these is just, you're right, there are several times floating around, at least usually 2 times, and it's knowing which one to use. Fine, that comes with practice there, okay? Any other particular questions, or we can just sort of dive into problems? Gnawing questions? Okay. Let's start with projectile motion then. That would be exam 2, and then we'll go backwards from there. So like, for example, number 2 here, you're going to see one of these where you have, oh no, actually number 2, you might not. Yeah, 2 and 3. Yeah, 2 and 3 and 4, all these are good problems. You want to work through these?
Yes.
Yes. Okay, so I have a ball that I kick at an angle of 60 degrees from the horizontal with a speed of 32 meters per second. At the top of the trajectory, what is the speed of the ball? This one is not that difficult. Let me show you why. I have this ball, I'm kicking it like this, and I want to know what is the speed at the top here. Now something I know about projectile motion is that my y velocity starts out big, gets smaller, goes to 0, and then gets bigger in the negative direction. The x velocity begins at a certain value, continues all throughout the trajectory, at that same value because AX is equal to 0. Yeah? So if I want to know the speed of the ball at the top, that's easy because all I need to know is what is Vx. And so Vx is equal to V naught times cosine theta. Let's see, what's V naught? That's 32 cosine of 60. So that's equal to 16 meters per second. So it's going to be A. That it's not really that difficult. It's just, you just have to recognize that the velocity at the top is only the x component of the velocity. So really this problem is just asking, hey, what's the x component of the velocity? And that's your answer. Now number 3 is a little more complicated, and this will be like your free response. What is the horizontal range of the ball? So I want to know what is this value for x. And in order to do that, I have to do several things. First, I have to find the time. In order to do that, I say that v at the top is equal to v naught y times or plus ayt, and this is going to be t top. Right, that's my first step. 0 equals 32 sine 60. That's my y component. Make sure you're up on your x and y components. It should be sort of second nature by now, that if I'm finding my x component, it's the vector times cosine. If I'm finding my y component, it's the vector times sine. The way I remember it, I mean, you can think about SOHCAHTOA and all that, but then you have to sort of go through, okay, what's O and H, what's A and H. I always remember, because it's alphabetical, that the x component is cosine, the y component is sine. X, then y, cosine, then sine. So cosine goes with the x component, sine goes with the y component. You just want to be able to do that knee-jerk reaction on your x and y components, because you have to do it quite a lot.
So whenever you do that, you use the initial velocity and then the sine and cosine of the angle?
That's right. And that gives me my y component. Minus 10 times t top. And let's see, what's 32 sine 60? I get 2.6. I mean, no, that's not right. The calculator doesn't work very well. I get 28. So this is equal to 28 right here. So t top equals 2.8 seconds. That means that t total, which is the time over here, is going to be 5.6 seconds. Now, if I want to know the range, the second part is to say that x is equal to vx times t. This is t total, not t top. So that's vx. We've already found vx. It's over here.
How'd you get t top?
Okay, so, sorry, I skipped a step there, didn't I? I said, put it over here. 0 equals 28 minus 10 t top. And so I subtract 28 from both sides. So I get negative 28 equals negative 10 t top. And then I divide both sides by negative 10. So t top equals 2.8. But remember, that's the time up here. So since I'm looking for the time down here, I have to double it to 5.6 seconds. Yeah, go ahead.
So why on the left side we couldn't use y? Use x.
On number 2, because I wasn't looking for the y range, I was looking for the x range. Because it says, what is the horizontal range of the ball? Because it asks for the horizontal range, that's x. If I was asking for the vertical range, then yeah, you're right, it'd be y.
I mean, like for the speed of the ball, we couldn't use y. But we wouldn't be able to use.
Right here? Can you repeat your question? I'm not sure I understand.
So you see how we use vx, we wouldn't be able to use vy.
No.
Okay.
The reason why
Yeah, that's
is that Vy is the magnitude of this vector. Right? Vx is the magnitude of this vector. This is the x component of the velocity. This is the y component of the velocity. The x component of the velocity is the same here, 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 and here. And I want to know the length of this vector.
okay.
But this vector is the same as this vector. But Vy, notice, starts out here then it gets smaller because I have a positive velocity, negative acceleration, it's slowing down. 0 right here. There's no Vy at all right here, and then it increases in the negative direction. It does. I mean, yeah, if you understand it, it makes sense. But if you don't, it can seem very obtuse and dense. Okay. So returning back to step 2 here, x is equal to Vx times t total. Vx, I know, is 16. I found that in the previous one. It's a great free response, by the way. Like this, I mean, not this exact problem, but this will be how your free response is laid out. Times t total, which is 5.6. What's that? 50, 80, like 90 meters it must be. That must be 90. Okay? Y'all with me? Expect a problem like number 3, where I'm asking for the total range, or the total height, or something similar to that. Expecting it? Yeah. I want good practice on this because you're going to see it on the test, and it's going to be worth more points. Number 4, you can see it on the test, but we're not going to worry about that one right now. Happened. Hold on, let me just close this. I'll reopen it. Something's wrong. I'm not sure what's up. That's okay. I have the other exams over here. Okay. What was that? Fall 18 maybe? All right, so we'll look at fall 18 here. Okay, there we go.
Exam 1.
That's exam 1, I know. Well, while we got it up, we'll look at it because you will see some stuff from exam 1. So you'll see stuff like adding up 2 vectors. Y'all clear on how to do that?
Can you do that one?
Number 24? Yeah. If you don't see it on the quiz, you'll definitely see it on the exam, but I'm pretty sure I put it on the quiz too. So I have 2 vectors. The vector A is 3 units at 30 degrees from the positive x-axis, so it looks like that. This angle is 30 degrees, and the vector B is 4 units along the negative x-axis, so it's 4 like that. I like to redraw these with my x and y components all on the axis. So here I have a 4 unit vector. Here I have a 2.6 unit vector. I get that from saying 3 cosine 30 equals 2.6. And then over here I have a 1.5 unit vector. That's 3 sine of 30 equals 1.5 units. So the first step when you're adding vectors is to find all the x and y components of each vector. Now I'll at least give you one vector on axis, and then I'll give you one vector probably off axis. Or if you look back at some of the old tests, sometimes I give you multiple vectors that are on axis. Those tend to be a little bit easier. I can show you what I mean by that in a sec. First step, find the x and y components. X is cosine, y is sine. The second step is you add together the x and y components. So if I were continuing with this, I would say 2.6 minus 4. That's equal to negative 1.4. So I would have a vector in this direction, negative 1.4. I'll just call it 1.4. And then in the y direction, I'd have 1.5. And you know what? I can sort of stop there because I know that this vector, which has two sides that are very, very similar to one another, 1.4 and 1.5, they're going to have an angle that's really close to what? 45, because it's almost an equilateral right triangle. So the answer right there is going to be C. But if I wanted to just double check my answer, I would say that I can redraw this. I'd have a 1.4, 1.5. The resultant vector will look like this. That'll be my angle theta. I would say the inverse tan, that theta is the inverse tan of 1.5 over 1.4. No, it's not 43, is it?
No, it's I use
Oh, right. Watch it, right? Because this comes out to be 43 degrees, right? Comes out to be 43 degrees if you do it in your calculator. But look, this is from the positive x-axis. But notice that the resultant of this vector is 43 degrees above the negative x-axis. So really I need to know what is this angle. I'm not sure that's 43 degrees. Let me double check that. 47 degrees? Okay, well good. So maybe you wouldn't be tricked into that answer. But it's 47 degrees. So if this is 47, that means that this is 180 minus 47, which is 133. So the answer is B. Be careful on those. Good news on the test, that'll probably be one of your free responses. So you won't be confused by the available options. That you'll just have, your own answer.
So if it says from, I'm sorry.
So go ahead.
If it says from, you have to subtract from.
No, it's just the important part here is from what axis are you measuring? All of these are from the positive x-axis, which is because this is in the second quadrant. That's why we subtracted 180. If we were in the third quadrant, we'd subtract, it'd be like 180 plus the angle. If we're in the fourth quadrant, we'd subtract it from 360. Now, in your quadrants helps. What is it?
So, do we even, could we have just drawn the resultant and known that, or, all that?
Could you just draw the resultant?
So the answer would have been between 90 and 180 degrees.
Oh, yeah.
Only.
Uh-huh. Yeah. You see what she says that
Oh, yeah, that's a shortcut.
because she knows, yeah, shortcut that. Because we know it's in the second quadrant, this is in the first quadrant, all these are in the first quadrant except for B is the only one in the second quadrant. So yeah, you're right. Okay. Let's look at some others. You'll probably see sort of a one of these type questions where it's just a conceptual question about where is this vector placed. Knowing your quadrants will help. And you'll also see one like number 26 where I'm asking you to do the graphical analysis. Just don't forget to look at this. Am I adding or subtracting? In this case, I'm subtracting, so don't forget then to write B in the opposite direction. And then the sum, or the difference in this case, as I start at the beginning and I go to the end. So the answer would look like C. Okay? I think y'all are good on those, right? All right, let's look at some more projectile motion, right? That's more difficult right now?
Yeah.
Okay. This was the exam we were looking at before. Oh, it's not doing it. We didn't do a horizontal one, did we? Let's do one like number 6. I'm pretty sure I put both types on there. I don't remember really, but those are important problems. I want you, if you mess up on these, I want you to mess up on the quiz, not on the test. So I kick a ball off like this, and I want to know what is the horizontal range of the ball. So I want to know what is x. I know that x is equal to vx times t. So I need to find t. I know what vx is. Vx is given right here. I know that because it's horizontal. It's kicked off horizontally on the top of the cliff. So all the initial velocity is in the x direction. With me? With me on that? Understand? Okay. So this problem, to find t, I just imagine dropping a ball from 20 meters. So I can, the same problem, if I just drop a ball 20 meters, then that'll give me the time that that's required to fall will be the same as the one on the left. So I say y equals v naught yt plus 1/2 at squared. Look, this is 0 because v naught y is 0. Y is negative 20 equals negative 10 t squared. So t is the root 2, which is 1.4 seconds. I divided both sides by negative 10, took square root of both sides to get root 2. Now that I know that, this 1.4 seconds, I can plug in up here. So I get x is equal to 5 times 1.4.
Wouldn't the A be
Negative
negative 5?
Since we're long day.
1/2.
Oh,
So it would be 2 seconds.
yeah, you're right. So this would be negative 5, and this would be 2 seconds, root 4. Thank y'all. So this is equal to 5 times 2, which is 10. Okay? Be careful. You can think that you know how you're doing it right, just like me. Like I think I'm doing it right, but then you just make a simple little mistake. And I know that on the last test, a lot of you, that was a lot of where you lost points. You just made, I think you probably knew it, but you just made simple little mistakes, and it led you to the wrong answer. But you know what? That's life, right? Like that's life. So you need to be prepared for that. And the MCAT and other tests, they're not going to care if you made a simple little mistake. They'll just count it wrong. I care if you get it right or not, but the MCAT people, they're mean. Like they are really, really mean. I've met some of them, and they're like jerks. Worst people you can imagine. Oh, I'm recording this, aren't I? Okay. No, I love them. They're awesome. Okay. You need to understand this, sort of the basics of projectile motion, right? Like for example, let's look at these. The x component of the acceleration is 0. Is that true?
No.
Yeah, true.
Zero, so yes.
The x component of the acceleration is 0. That means it doesn't accelerate in the x direction. That means the velocity in the x direction is always the same. So yeah, that first statement's true. The y component of the velocity is 0 at the top of the trajectory. Yeah, that's true. V top equals 0. The magnitude of the x velocity is greatest at the beginning. True or not true? Well, it's constant.
It's constant throughout.
Right, it's constant throughout. So Vx is always the same, so that means it's not greatest at the beginning. It's always the same. And then the acceleration in the y direction at the top of the trajectory is 0. True, right?
Yes.
No.
Wait.
No.
Oh, the velocity.
Yeah, the velocity is 0. So we just had 1, 2, it's just 1 and 2, right? So C. Yeah, just 1 and 2. But just reviewing your notes, you know, there are a bunch of different statements, and I can word them all different ways. If you look back at old tests, you'll see how I word them differently.
Are we gonna have stuff like that on our quiz tomorrow?
Yes!
Okay.
Okay? So that's why I'm talking about this question. All right? And then we're getting into forces. Let's look at another one. That was fall 18. Let's look at fall 17. There, yeah.
Is there a particular question that involves finding the line?
Yeah.
Like the height.
Like number 1 right here?
Oh, yes.
Yeah. You want to do this? It's similar, but it's a little bit different. all these projectile motion problems, they're a little bit different because you ask for different things, or you might even have some sort of different conditions that you're starting with. To have a ball is thrown in the air at 30 degrees to the ground, initial speed of 40 meters per second, how long will it take to reach its maximum height? So, oops. My ball. I know this angle is 30, and I want to know, well, I want to know how long will it take? And then we'll ask what is the y height after that, because that was really the question you asked. But here I just want to know how long does it take to get up to this point, to reach its maximum height. So I want to know what t-top is. But I know that v-top in the y direction is equal to 0. So I can say that vy equals v naught y plus a y t. So that's 0 equals what's my v naught? 40. 0 is equal to 40 sine of 30 minus 10t. That's 20 minus 10t. So in order for that to equal to 0, t top equals 2 seconds. Subtracted 20 from both sides, divided both sides by negative 10. Y'all okay solving that? I'm skipping a step here, but that's why I like using 10. I like using nice round numbers so that the math works out more easily for you, because I have a factor, or I have a multiple of 10 here, and so I know that this has to be 2 for t for this to equal 0. Get used to that, okay? It'll make you move faster through the exam if you can work through these equations more quickly. So t-top is 2 seconds. Oh, that's the answer. All right. Now, if I wanted to know the maximum height, so let's say I wanted to know what is this height, I would say y is equal to v naught y t plus 1/2 ay t squared. Well, the time that I'm using here is t top. Nope, not doubling it. Like, I'd only double it if I'm looking for what value? The x range, right? Because the x range, I want to know the position over here. But right now, I want to know the position right here. So I use t top. Whatever position I'm looking for, that's the time that I use, the time at that position. So this is 40 sine 30 times 2 minus 5 times 2 squared. This pink calculator is terrible. If you're ever missing a calculator in your exam and I try to give you this one, say no thank you. So that would, I get 20. Good. Appreciate you. All right. So that's the y height. And then if I want to know the x range, I already know Vx. Wait, no, I don't know Vx. It's 40 cosine 30. And then the time that I use there, gosh, what time do I use there?
Double it.
I double it. So I use 4 seconds for the time there. And that's whatever it is. 160 times 0.86. 100 or so. All right. What is it? What's the answer? 139. Okay. Cool. Good with that? On the quiz tomorrow, okay? On the quiz. Let's see, let's look at this. Which of these apply? The y component of the velocity changes direction during flight. That's true? Yeah, it initially starts going up, then it's going down. The y component of the acceleration is always negative?
Yeah.
Yeah. The y component of acceleration is always negative g, right? Negative 10. The maximum speed is at top of the trajectory? No, because you're missing the y component completely, right? The maximum speed is either at the bottom, right before it leaves, or right after it leaves, and right before it hits. So the time in flight is determined by the y component of the velocity. That's true. Okay.
No,
That's false.
Answer C.
because it's the.
Oh, right. Oh, I'm looking for false answers. Right. You're right. Glad y'all are here. Failed this quiz. Okay. Let's sort of skim through these. There's a horizontal range. That's like where I'm kicking it off horizontally.
Can we work one like we did yesterday in class? It didn't go all the way to the bottom. It went to like.
Like a mountain.
Yeah, like.
Yeah, let's do one of those. There was one on that previous exam.
Is there gonna be one of those components?
I don't remember, but they're not real complicated because,
Maybe for you.
well, no, they're not complicated because if you know the time, it's really a single step. It's just knowing how to do it. So let's go ahead and do it. I don't know if it's on the quiz. I'm not sure. So this fires up like this, and then it lands on a table. And I know that the time right here is 1.5 seconds. I know that this speed is 20 meters per second. And I know that this angle is 30 degrees. And I want to know what is this y position. I want to know the y position of the object at 1.5 seconds. So let's say y is equal to v naught y t plus 1/2 ayt squared. Oh, and by the way, like I gave you this too, which is the x range, but you don't need that at all. Like that's just extra. It's just a little something extra for you. Okay? All I need to do is to plug in the appropriate values here. So I have 20 sine 30 times 1.5 minus 5 times 1.5 squared. No, not bad. Now the one that we did yesterday with the quadratic, it was similar to this, except I didn't give you the time. And that's when these problems get difficult if you don't have the time, because then you'll either have to use the quadratic or you'll have to solve a system of equations like we did on the last test. Remember we had the two equations with two unknowns? But you're not going to have to do that on this test or on the quiz. Not till chapter 4. Okie dokie? Not hard, right? Like that would probably be good to have on the quiz, but I don't know if it's on there or not. Did I clear this?
It's D.
Oh, the answer is D?
Yeah, I think that's like 5.
Sorry, I don't want to use my crappy pink calculator. The button stick. Okay, folks, can I close this one? Clear this ink? All right, let's see, that's all. Let's look at another one. We'll go another year back. That was 18, 17. Let's look at 16. At some point, these all start looking the same, right? I hope they start looking the same.
So that was the asking for the extra component.
Which one, number 1?
No, I think number 3. Same. It's asking the distance from the launch point.
Uh-huh. Number 1, we can come back to number 3.
Alright.
But number 1, sorry, my thing is not working. That's the thing for just a second. Number 1 is asking, it seems complicated, but it's not, because it's asking for the horizontal velocity at the highest point in its path. Then what would I have to do to find that?
Nothing.
Well, I have to do something. What would I do? No, I don't have to do all that business.
Really, you just have to find the velocity, the horizontal, so the sine, or, yeah, cosine.
Cosine.
100 cosine 30.
100 cosine 30. That's all it's asking for. It's just asking for the horizontal velocity And because the horizontal velocity doesn't change with time, right, then it's
Vertical
just,
velocity would be zero.
huh?
So the vertical velocity.
That's right, yeah, the vertical velocity would be zero. That'd be a good question too, right? But the horizontal velocity is, it's not a trick.
No, it's true.
Yeah. So the horizontal velocity is just V naught cosine theta, or 100 cosine 30. Or 86.6. Okay. Now want to do number 3? We've done number 3. Let's scroll down and look at some others. Number 3 is just like the one that we did before. That's where I have an object and I'm finding the horizontal range. First, I would find T top. Then I would find T total, just doubling it, right? And X would be equal to Vx times T total, where Vx is V cosine 30. We can come back to that, but let's sort of scroll down through some of these others.
Can we find one where it's elevated and then it's launched at an angle? Because that one was weird for me. So you have to find like 2 lines.
You're not going to have to do that.
So good.
Yeah, so like the one we did in class. Yeah, so I mentioned this, that when you have the quadratic, you won't have to do that on the exam or on the quiz. Okay? I just did that just to show you guys, hey, if you encounter a problem like this on some other test of praxis or whatever, that if you're doing a physics praxis. All right. Or the MCAT or the DAT or I don't know, whatever test it's the GRE. Right. Let's look at another one. Number 3 is a little bit different. So this is a similar problem as what we had before, but the velocity is not given. Okay, and I'm asking here, what is the initial velocity? So don't be thrown off on these. If it looks like a problem that's just a little bit different from what you've seen before, just take a big deep breath and just start writing down stuff that you know. Okay, and then as you start writing down stuff that you know, it'll come to make sense, I hope. So first of all, this is what I'm doing. I'm shooting a ball in the horizontal direction. I know that this height is 20 meters, so that's y. And actually, I know that it's negative 20, right? Because it starts at 0 and goes down 20. And I also know that x is equal to 3 meters. I don't know what the initial velocity is, but I know that it's at an angle of 0. So I know that x is equal to Vx times t. That's one of my kinematics equations for projectile motion. Remember, this is because if ax is equal to 0, I get rid of that 1/2 at squared term. So my initial velocity is this value right here. So if I know x and t, then I can find my initial velocity. Huh? Oh, shoot. I don't know t. I know x, but I don't know t. So I have to find t somehow. But this is an object that's dropping 20 meters. So I can find the time for any object to drop 20 meters. I know my acceleration. I say y is equal to v naught yt plus 1/2 ay t squared. But this goes to 0 because v naught y is 0. Because it's horizontal. Yeah, so v naught y, the initial velocity in the y direction, since this is all in the x direction, v naught y has no value. It's 0. So it's going to be negative 20 equals negative 5 t squared. So t is equal to 2. Then, right, square root of 4. I can plug that in up there, and Vx is equal to x divided by t. That's 3 divided by 2, or 1.5 meters per second. So don't freak out if it looks a little bit different. Like if I don't give you the initial velocity, but I give you something else, you'll still use the same procedure to answer. You just might have to work from a different direction. I always find it helpful to write down those equations. Let me write them down for you. So remember we had two sets of equations. These are just the kinematics equations, but they're just written with the subscripts, and they're written with the values for AX included. So X is equal to VXT, and then also Y equals V0YT plus 1/2 AYT squared, and Vy equals V0Y plus AYT. There was another companion equation. It looked like this, but it was just Vx equals V0x. So it just says that Vx doesn't change, that the velocity in the x direction is equal to the initial velocity in the x direction. But hopefully on the quiz tomorrow, you don't have a whole lot of time. It's really a time, like a time practice, because I want to get you in shape for the exam to make sure that you can go through these things quickly. That'll help you on the exam. You don't have a whole lot of time in messing around. If you want to scratch this down on your paper before you get started, that's fine. In this case, V0Y was equal to 0 because it's at a horizontal. All right, let's skim through these. Don't forget on these that the time, which of these hit first? Target 1 or target 2? 1, right, because it's at a lower height. And anytime it's at a lower height, that means that it spends less time in the air. Doesn't matter about the x range, it's only the y range.
So if three different objects have the same y range, they'll just around at the same time.
Right, yeah, we had a concept test like that yesterday, where I had a football player punting a ball, and it sort of went like this or like this. And because they're all at the same height, they all take the same amount of time. Now, they have differing angles and initial velocities, but they all take the same amount of time. All right. You want to look at vectors some more?
Yes.
Okay, so let's go back to exam 1. Let's do another one. Okay, no, let's look at 27. We haven't done one like this. So a vector has a negative x component and a positive y component. Already, I know it has to be in the second quadrant. So boom, boom, boom. Oh, no, that one stays. It has to be what?
He's going there.
If it's in the second quadrant,
It's 90 to 180.
yeah, 90 to 180. So that goes away. That goes away. That it has to be D or E, right? Because it's 90 to 180. It's in that second quadrant because it has a negative x component but a positive y component. Now, the magnitude of the y component is bigger than the x component. So this vector is actually bigger. That means that the sum of those two vectors is going to be up here. So it's going to be between 90 and 135, which is 100. So E is the right answer. You'll probably have a question like that.
So
pretty
vice versa. So if x is bigger than y, it's going to be between 135 and 180.
Right. If the x component was bigger, that means that this vector would be bigger, so it swing the resultant down into this, what do you call that, like a subquadrant or something, down in the lower part of the quadrant.
So if they're equals, it's going to be at like a 45.
Right. If they're the same size, they're parts of an equilateral right triangle, so they'll have an angle of 45 degrees.
So whatever size is bigger, that's where it's going to
Mm-hmm.
land.
Yep. The resultant lands closer to the bigger vector. That's a good way to think about it, and that'll always be true. All right. Burning this business up. Let's look at a different. We did one like that. I want to show you another type. I can find one. Okay, you just need to know how to find the x and y components. So here I have 14 and 30 degrees below the negative x-axis. I just want to know the magnitude of the y component, although it's useful for me to draw that vector. It's right there, 30 degrees below the negative x-axis. That's not important for this one, for this particular problem, but it's a good practice. And so if I want to know the y component is equal to 14 sine of 30. All right, so it's 7. Okay? That should be an easy one. Like most of the problems will be, oh, boom, boom, boom. I know the answer to that. But then some of them you have to spend a little time calculating. Still not seeing what I want to see. 16. Oh, I didn't get chapter 3 on this exam. Okay, well, let me just show you an example. So I might give you a question where I give you 3 vectors, but they're all on the x or y axis. So like I might tell you that there was a problem I was looking at earlier. And again, I don't know if it's on your quiz, but where a person walks like 4 meters to the west, 3 meters to the south, and 5 meters to the east. What is the resultant of his displacement? And so I write down my quadrants, or my coordinate system, east, north, west, south, and then I draw my vectors. 4 meters to the west, 5 meters to the east, and 3 meters to the south. So this one's a little bit easier because I don't have to find the x and y components, right? Because they're all on either the x or y axis. So I get to skip that first step. And if I do this, I get a 1 meter vector over here. 5 minus 4 equals 1. And then down here I get 3 meters. And so if I were looking for the magnitude of that resultant vector, I would say the square root of 1 squared plus 3 squared. So square root of 10. Huh? Oh, Pythagorean theorem. So I have a triangle here that is 1, 3, and so it's 1 squared plus 3 squared is equal to c squared, where this side is c. Right? A squared plus b squared equals c squared. That's from our Pythagorean theorem. Okay? I can answer more questions if you have, but that's sort of the brunt of the quiz.
So when you say find the displacement, you're basically drawing C. That's what
Right. Yeah, it's always going to be just add up these vectors and tell me what the result is, or what is the direction of the vector. I can ask you here first. Any other questions? All right, chill just a second. Let me get the names here. Let me stop this.